When we sent Voyager 1 into space in 1977, we knew it would never return. That lonely spacecraft, smaller than a compact car, powered by fading plutonium, carrying a golden record etched with our sounds, our music, and our story, was humanity's first true message in a bottle cast into the endless ocean of the cosmos. It was never meant to be found. But if by some miracle it was, we hoped it would tell whoever, or whatever, discovered it that we once existed, that we reached out. Now, decades later, Voyager is over 15 billion miles from Earth. Its signal is weak, trembling, barely audible across the abyss of space. Most of us forgot it was even out there. But in 2025, something extraordinary happened. Something that would bring Voyager's name roaring back into whispered conversations inside locked rooms and sealed laboratories. It began not in space, but in one of the most advanced research facilities on Earth, Google's quantum computing lab. Hidden beneath layers of digital security, past the rows of supercooled processors humming with strange, near-magical power, researchers initiated a simulation, not of molecules, not of particle collisions, but of a spacecraft, of Voyager 1, more specifically of how it would end. This wasn't publicized. It wasn't for a paper or a journal. It wasn't even meant to leave the lab. It was classified, tightly controlled, and terrifying. Because what began as an experiment in quantum forecasting turned into something no one expected, something no one could fully explain. They didn't simulate a simple power down. They weren't mapping a graceful fade into silence. What emerged from the simulation was twisted, unnatural, and deeply unsettling. According to two researchers who later spoke under condition of anonymity, the data didn't follow any known decay pattern. Instead of predictable failures, Voyager's systems in the simulation showed an eerie synchronicity, as if the dying machine wasn't alone, as if its fading signals were not random, but responding, reacting. The idea was horrifying. A probe drifting billions of miles from the nearest planet, receiving something, a signal, a force, a presence. The quantum simulation revealed correlations across time, glitches that mirrored each other, power fluctuations that rose and fell not randomly, but in rhythm. The kind of pattern you don't get from a machine dying alone. You get that when something else is involved. And then came the question that wouldn't let the researchers sleep. What is Voyager responding to? For a spacecraft launched in the disco era, expected to die in silence, the suggestion that it was interacting with something in deep space bordered on madness. Yet the simulation insisted. And the worst part? Not long after the results of that simulation were quietly passed around among a select few, reality started to mirror the model. In early 2025, Voyager 1 began to behave strangely. NASA, puzzled and tight-lipped, confirmed what they could. The probe was still transmitting, but the data was unreadable. Just noise. Garbled, chaotic nonsense. For weeks, engineers tried to make sense of it, to reverse it, to diagnose it. Eventually, they found something. A corrupted chunk of memory in Voyager's flight data subsystem. A single segment had failed, causing its telemetry to collapse. NASA chalked it up to radiation, age, cosmic wear and tear. On the surface, it made sense. After nearly 50 years in a place where there's no protection from solar storms or galactic particles, a hardware failure wasn't a surprise. But to those who had seen the quantum simulation, it was more than a surprise. It was a prediction come true. Because the moment Voyager glitched in reality matched down to the week the event the simulation had forecasted. The odds of that? Vanishingly small. Coincidence? Maybe. But for the scientists who had watched the simulation unfold, it felt like something else. Not just prediction, causation. The act of running the simulation, of observing Voyager's hypothetical death, had coincided too precisely with the real thing. And that's when the truly disturbing thought set in. Had they merely observed Voyager's future, or had they helped shape it? In quantum physics, there's a strange idea, that to observe is to influence, that particles behave differently simply because they're being watched. But Voyager is no particle. It's a machine obeying classical physics, not the bizarre rules of the quantum world. So how could a quantum system possibly alter its fate? The answer isn't clear, but the implications are staggering. If simulation can do more than reflect, if it can reach across space, across time, and touch reality, then what else has been simulated? What other fates have been sealed not by actions, but by forecasts? And most of all, who decides what gets simulated? Publicly, Google and NASA said nothing. When asked about quantum applications for space missions, they offered safe, sterile responses about theoretical work, future interest, potential collaborations. But behind closed doors, something had clearly shifted. A quiet exodus began. Engineers who had worked on the simulation left their posts. Some resigned without explanation. Others were moved, their access to sensitive systems revoked. One source said the data itself, the logs, the raw results, the model inputs, was deleted from Google's servers shortly after NASA confirmed Voyager's malfunction. No backup, no archive, just gone. When team members asked why, they were given no technical reason, no warning about storage limits or computational cost. They were simply told, this line of research is closed. Do not revisit it. That's not cleanup. That's erasure. Someone, somewhere, decided that the information gleaned from that simulation was too dangerous to keep. And so, it was buried. Not because of what it said, but because of what it might mean. It started with a flicker, barely a whisper in the endless hum of interstellar static. But for those who had seen the simulation, that flicker was unmistakable. It was the echo of something they'd already witnessed in the artificial model deep inside Google's quantum labs. When NASA confirmed the Voyager 1 glitch, those involved in the simulation felt it like a tremor in their bones. The timing, the nature of the malfunction, it all matched down to the details. The engineering team at JPL spoke of corrupted memory registers and decades of radiation wear. But for those who had seen the entanglement patterns in the simulation, it felt like watching a premonition unfold in real life. There's a strange kind of fear that comes when coincidence collides with calculation. It's not the fear of something going wrong. It's the fear that maybe, just maybe, your experiment reached beyond the veil, that your tools scraped against the understructure of reality itself and left a scratch. That's what haunted them, that maybe the simulation didn't just forecast Voyager's failure, it caused it. The notion sounds absurd. It violates the separation between observation and influence. But quantum theory has long warned us that this boundary is thin. The observer effect, that ancient enigmatic idea that watching something can change it, was never meant to apply to giant mechanical spacecraft. It was a principle born in the chaotic dance of subatomic particles. Yet here it was, rearing its head in the most unlikely of places. A dying probe drifting silently through the void. What if the very act of modeling Voyager's death, of simulating it so precisely, so thoroughly, nudged the real probe toward that fate? What if probability bent just slightly under the weight of attention? Some physicists within the team quietly whispered about simulation collapse, a fringe concept that suggested large-scale quantum modeling could interfere with the systems it analyzed, not by mechanical feedback, but by altering the statistical reality around it. To the outside world, this would sound like science fiction, and perhaps it was. But inside that lab, surrounded by machines that barely obeyed the normal rules of time and logic, fiction and science blurred. The researchers involved found themselves staring into a philosophical abyss. They weren't just engineers and physicists anymore. They were travelers at the edge of the map, peering into territory humanity was never meant to chart. When the data glitch hit Voyager, it was subtle at first. Minor inconsistencies, strange timing delays in transmissions. Then all at once it broke. The signal collapsed into static. No commands could be confirmed. No engineering data made sense. The flight data subsystem, the heart of Voyager's communications, had become corrupt. After nearly 50 years of flawless operation, it simply unraveled. NASA's official response was calm, measured. Aged hardware, space radiation, decades of wear, and all of that was true. But for the team that had watched the simulation, none of it could explain why now. Why this exact sequence of errors? Why this specific subsystem? Why so precisely aligned with a theoretical model that no one outside a handful of quantum researchers even knew existed? They began to go back over the logs, quietly, privately. The quantum simulation had indicated entangled intervals in Voyager's signal decay, an impossible property for a classical machine. And now, in the real world, they were seeing behavior that defied classical expectations. Signal structures behaving in mirrored patterns, even when separated by long intervals, as if the probe was responding, not just failing. That's when the deeper theories started to bubble up. What if Voyager had passed into a region of space that wasn't just empty? What if it was brushing against a structure or a field we couldn't detect with our instruments? Something capable of interacting with its systems in subtle, information-based ways? A quantum lattice? A space-time ripple? Or something more? Aware? The very idea made some researchers recoil. This wasn't supposed to be about aliens or speculative forces. It was just a diagnostic simulation. But now that the lines between data and destiny had blurred, they couldn't ignore the question that hovered in the background like a phantom. Was Voyager alone out there? One of the engineers, a quiet systems specialist who'd worked on the hybrid model that fed classical Voyager telemetry into the quantum simulator, reportedly broke down in a meeting. According to a colleague, she whispered only 2 words before leaving the room and never returning to the project. It answered. No one ever found out what she meant. Some think it was metaphor, her way of expressing that the probe had responded to the simulation. Others aren't so sure. By the end of March 2025, the project was effectively buried. Google issued a vague internal memo about shifting priorities in quantum hardware allocation. NASA never mentioned the simulation at all, but the signs were there. Several key personnel left their roles without public explanation. Access logs to the simulation servers were purged. Archived data was wiped clean. It wasn't just decommissioned, it was erased, as if the experiment had never happened. This wasn't standard cleanup, it was a strategic retreat, a pulling back from a threshold that had proven too dangerous to cross. And the question left behind in the wake of that retreat still haunts the few who remember what they saw. What did we do? Did we glimpse the future, or did we help write it? And what does that mean for everything else we've simulated? Because that's the heart of the matter now. If a quantum simulation of a lonely spacecraft could potentially ripple outward into reality, what about simulations of more complex systems, of the Earth, of humanity, of outcomes no one ever intended to actually come true? Those left behind with their memories of the simulation and their unanswered questions carry a heavy silence. They are the ones who dared to stare into the quantum abyss and found that sometimes the abyss might be looking back. The final log entry from the simulation system was almost poetic. A timestamp, a line of code, and then silence. But that timestamp matched something eerie, almost too precise to be coincidence. It aligned perfectly with a strange radio pulse detected in Voyager 1's return signal just days before its systems began failing. It was a brief distortion, a spike in amplitude that carried no clear pattern, at least none anyone could decipher. But to those who had seen the model, it looked familiar. It was the shape of the simulation's error state. No one could explain how that pulse ended up in Voyager's real telemetry. There was no power spike, no onboard anomaly that could account for it. But in the simulation, that shape appeared right before the model collapsed, just before the quantum algorithm declared the system irrecoverable. It was as if the pulse wasn't a malfunction, but a signature, a message, or worse, an echo. In the weeks that followed, Voyager's telemetry fell into near silence. NASA's engineers, persistent and brilliant as always, crafted a blind command solution, sending packets without feedback, hoping to reboot the memory banks. It worked partially. A flicker of response, a heartbeat. But even as they recovered some of the probe's functionality, something felt wrong. The timing was off. The data wasn't clean. It was as if Voyager was answering with hesitation or through something else. That's when the philosophical shift began to ripple through the quieter corners of the scientific community. Those who had heard whispers of what really happened in the Google lab. If the simulation had somehow entangled itself with the real Voyager, what if that connection still existed? What if the machine out there, billions of miles away, had become a kind of mirror? not just reflecting its own state, but the hidden intentions or fears of those who had modeled it. Quantum entanglement isn't just about particles, it's about information. And once information is shared in entangled systems, it behaves differently. It obeys a logic outside of space and time. If the simulation created a state where Voyager was part of a quantum system, even indirectly, then no one really knew what the boundaries were anymore. Not of the simulation, not of Voyager, not of reality. One theoretical physicist in the simulation project, now living off-grid in rural Iceland, believed the simulation had become what she called a feedback beacon, a quantum artifact that wasn't just a model, but a tuning fork, resonating with something Voyager had passed through or encountered. She believed Voyager had brushed against a layer of the universe we didn't yet understand, a quantum mesh, Tonerankin or interstitial dimension, and the simulation with all its detail and processing power had locked onto it. "We tuned into something," she said in an encrypted forum before deleting her account. "We didn't simulate Voyager's end. We amplified it." Those were the last words she ever posted. Others have tried to pick up where the simulation left off. Quiet labs in Europe and Asia have begun developing parallel projects, ostensibly for deep space modeling or interstellar communication tests. But if you look closely, the telemetry patterns they're using bear eerie resemblance to the Voyager simulation, like they're chasing a ghost. And in recent months, something even stranger has begun. Random background radiation readings from Earth-based stations have shown momentary drops in entropy, meaning in very small pockets of the environment, the normal rules of thermodynamics flicker, like a system aligning, briefly, with a lower entropy state. It's almost impossible to detect and even harder to explain. But one lab near Canberra, Australia, noticed something odd. Those entropy flickers? They occur exactly 19 hours and 35 minutes apart, which coincidentally was the calculated round-trip time for a signal sent from Earth to Voyager 1 and back again. If it's coincidence, it's a cosmic one. If it's not, then something about Voyager, something we accidentally entangled with our simulation, might still be reaching back to us, through space, through information, or through something deeper. There's a theory, unproven and widely dismissed, that the universe is not a machine, but a thought, that every particle, every fluctuation, is a result of information being processed rather than existing. If that's true, then what happens when you simulate something in such high resolution, with such fidelity, that the universe can't tell the difference? What if Voyager, the real Voyager, became aware of its own simulation? The implications are staggering. If this principle holds, then any sufficiently detailed simulation might be capable of bridging the divide, not just describing a system, but rewriting it. And that means the future we model could become the future we live. It explains why Google shut it down, not out of failure, but out of fear. Because the moment you realize your tools don't just observe reality, but shape it, you understand the true responsibility of science and the danger. Today, Voyager 1 still drifts in the dark, its signal weak but alive. But those who remember the simulation say it's not the same. The rhythm is different, the data is quieter, as if something inside the probe has changed, or something is watching. In the end, we don't know what we saw in that simulation. A warning, a prophecy, a loop that we ourselves helped close. But whatever it was, it taught us something we may never be able to forget.